Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, you should recognize this. We've seen this in the past. Rewrite this as n to the power of 1 over n. So if you look at this here, this is very similar to this, and then you've got over n over n. So you should have a hunch that it. Well, let's just say that you didn't know this. So let's try and evaluate this from scratch. So we're going to try and evaluate this from scratch. So let's say y, let y be what we're trying to find here. So we are trying to seek this, but in effect we're going to seek y. So from here natural log equally to both sides. So that will then give you this. This will come down here. That will then give you this natural log, the bubble here, the bubble here. So now imagine this as being one block multiplying another block. This one here gets multiplied to the top. So that will then give you this. So now let's check it. Let's check it as n tends to infinity. As n tends to infinity, natural log of n plus 1 will head towards infinity, and then this will head towards infinity. So here you've got infinity over infinity. So it's an indeterminate form. So you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate the top. That will then give you this. Differentiate the bottom. That will then give you this. So here you've got this divided by 1, which really collapses down to this. So this thing is the same as this thing. So now as n tends towards infinity, this thing here, the denominator is just going to get bigger and bigger and bigger and bigger. So you're going to have something very, very, very big. So which will mean this whole thing's heading towards 0. So which will mean that this block here will head towards 0. So from here, exponentiate both sides. So exponentiate it. These two in a way cancel out, leaving you with y, and then this here equals this. So the limit is actually 1. So the limit of this whole thing here is 1. Okay. So next question. Find the limit of this as n tends to infinity. So press pause and have a go. Okay, so to do this, remember natural log of a minus natural log of b. That's the same as natural log of a divided by b. So rewrite this as this. Rewrite this as this. So now you can see that as n tends to infinity, as n tends to infinity, you're gonna get something similar to n over as n tends towards infinity, this is going to become very, 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 very big, and then you're going to add a tiny insignificant amount onto it. So as n gets very, very big, let's just forget about this one. It really becomes n over n. So n over n is like 1. So natural log of 1, remember your natural log graph, natural log of 1 is 0. So as n tends to infinity, this whole thing here will head towards 0. So the limit of this is 0 as n tends to infinity. Okay.